Hi, I'm Michelle Sheran-Andrews, and in this video, I'll discuss the Graphing Indifference Curves help sheet. Before you read this help sheet, take time to recall these definitions and concepts. This list and all the others you'll see in this video can be found on Sakai. Once you do that, you can look at the help sheet. From this help sheet, you should be able to explain all of these concepts presented here. Now it's time to apply what you've learned. Let's work this practice problem. Here we have an individual with a utility function u equals x to the 1/2 plus the log of y. We need to determine if each of the following statements is true or false and be able to justify our answer. So let's start with the first statement. Both good x and good y are good goods. To do this, we want to look at the sign of mux and of muy. In this example, mux is 1/2 x to the minus 1/2, which can also be written as 1 over 2 x to the positive 1/2. Now, assuming x is positive, which we'll assume, this is a positive sign. That means that as x goes up, utility goes up. As the consumer consumes more of good x, her total utility goes up. That means more is better. Muy, given the utility function here, is 1 over y. Again, assuming a positive y, muy is also positive. This means that as consumption of y goes up, total utility goes up, more is better. And for both of them, we can flip that. As consumption goes down, total utility goes down, so less is worse. Therefore, we see that both goods are good goods. Statement A is therefore true. Let's now look at statement B. Do the indifference curves slope up? Well, in the case of two goods, indifference curves necessarily slope down. That's because there has to be a trade-off. As the consumer consumes more of, say, good X, utility goes up. So to be indifferent, to remain as well off, consumption of Y would have to go down. Or if consumption of X goes down, total utility would fall, so to remain as well off, consumption of the other good would have to go up. Indifference curves thus slope down, which makes statement B a false statement. Now let's look at statement C. What happens to the MRS as X increases holding Y constant? To answer this question, let's first write down the MRS. MRS as a ratio of marginal utilities. Here is MUX, or 1 over 2x to the power 1/2, divided by MUY, or here 1 over y. This can be written as y over 2x to the power 1/2. So what happens to this fraction as x increases holding y constant? Well, first let's just look at it. X is in the denominator. So holding y constant, as x goes up, the denominator gets bigger, which will make the fraction fall. We can also see that mathematically by looking at the sign of dMRS dx. To do so, I have a personal preference of going up here and writing this as such. So what do I get? I get minus 1/2 times the constant y over 2 times x to the power minus 1/2 minus 1, or minus y over 4 x to the minus 3/2. This minus sign tells us that the derivative is negative. So as x gets bigger, holding y constant, the MRS gets smaller. Therefore, statement C is true. The MRS does decrease as x increases, holding y constant. Now let's turn to statement D. Does the MRS decrease as y increases, holding x constant? Well, first let's eyeball it. Y is in the numerator of the MRS. So, holding x constant, as y increases, the numerator increases, causing the MRS to increase. Let's see this with some math. We can answer this question looking at the sign of dMRS dy. Here we get 1 over 2x to the power 1/2, which is positive. As y goes up, the MRS goes up. Positive sign means there's a positive relationship between y and the MRS. So this statement is false. As y goes up, the MRS doesn't decrease, it increases. Now let's turn to statement E. True or false, the indifference curve sloped down at an increasing rate. Well, we know that the indifference curve sloped down from statement B, and we know something about the rate from looking at statements C and D. Because the indifference curve sloped down, and if we want to look from left to right, we will think about what happens to the slope of the indifference curve as x goes up and as y goes down. As x goes up, the MRS we have already determined decreases. So from left to right, as x goes up, the slope of the indifference curve gets smaller. Well, what happens from left to right to the slope of the indifference curve as y decreases? We've determined that dMRS dy is positive. That means that as y goes down, the MRS will go in the same direction, down. So from left to right, as x gets bigger and as y gets smaller, the MRS should decrease. That means the indifference curve flattens out, and so the curve slopes down at a decreasing, not increasing rate. This curve slopes down at a decreasing rate, making statement E a false statement. Now let's look at this last statement. To determine whether the consumer is willing to give up decreasing amounts of Y as he consumes more X, we're going to draw and look at a graph. Here we see our downward sloping indifference curve, where the curve slopes down at a decreasing rate. Let's map out increasing X by 1 unit, both high up on the indifference curve when the consumer doesn't yet have a lot of X, and then further down along the indifference curve when the consumer now has relatively more X. From A to B, I show the consumer consuming 1 more unit of X, and then from C to D, also I show the consumer consuming 1 more unit of X. Now let's see how much Y he's willing to give up to get 1 more unit of X from A to B, and compare it to how much Y he's willing to give up to get 1 more unit of X from C to D. What I want you to observe here is that from A to B, the amount of Y that the consumer is willing to give up to get 1 more unit of X is more than the amount of Y that he's willing to give up from C to D. So the consumer is indeed willing to give up smaller and smaller, thus decreasing amounts of Y as he consumes more and more units of X. This final statement is therefore true. Now you're ready to go beyond the surface of this help sheet by analyzing and evaluating. To help you with that, distinguish, compare, and contrast using this list. Finally, go even further beyond by creating. Here I have a list of utility functions that I've asked you to formulate. You'll want to take your answers to recitation so you can share and compare with those of your classmates. This concludes the Graphing Indifference Curves video.